issues, but it's working now. So welcome to the another Aberdeen ICorr Aberdeen Corrosion Forum, annual Corrosion Forum. It's the second year that we are doing this as a Corrosion Forum, and it has been many years that we were doing this as in the form of Corrosion Awareness Day, which was really for the younger engineers to make them familiar with the corrosion field. But now it's in the form of forum with different themes. So last year it was CUI. And this year we are doing it. That last year was hosted by Track, and this year we are doing in the theme of energy transition and renewable energy. So this topic has been selected by the last year's attendees by a survey. So they selected this topic as something very interesting for them. They wanted to know the importance of corrosion management, material selection in this era. So today we have different speakers online, in person, pre-recorded, because we wanted to include several people from and speakers and companies from all over the world. So we'll have speakers connecting from Canada. I think will be very, very early morning for them. And we'll have from Middle East, and we'll have people from UK in person here. Also, we are pleased to have our ICorr president for the first time in Aberdeen, Bill Hedges. So very pleased to have him here for the first time, and he's attending today as a keynote speaker on behalf of ICorr. Our sponsor this year is Preserve. Stuart sitting there kindly has sponsored today venue and the catering, and helped us a lot in organizing the event this year. And their partner Stopak, they will have demonstration outside. I think it will be after lunchtime. Yeah. So there will be demonstration, and then will be hands-on experience as well for the attendees to use their product, which is a product developed as a solution to address waste reduction and lowering CO2 in fabric maintenance and asset integrity solution. So they will have the demonstration later today. We have something about 49 number of delegates today. 34 in person, and we will have a representative from our sponsors, branch sponsors attending today. And also, as you might be aware, we have a young engineer program running this year in Aberdeen for the first time in Aberdeen, and most of them are attending today either online or in person. So it will be a very good opportunity for them to have a networking with experts, speakers, presenters today. So I encourage them to reach out and talk to the experts today. With regards to the agenda, so I will just quickly show you the agenda. You should have it already. So we'll start with a keynote by Bill Hedges, ICorr president, and then we'll have an online presentation by Muhsen Elhaddad, and then we'll have a break and continue with Frank Cheng from University of Calgary. Again, there will be online session, and then Shravan Kairi, which is here, we will have another presentation in person. So this will cover the pipeline session. Then we'll continue with the offshore wind session with two presentations. Anthony Stady who is online at the moment, and he will have his presentation online, and Simon Daly will continue from Safina Group with the in-person presentation. Then after another break, we'll have solar, nuclear, and fusion energy session, which will be done in person by Jovan Lim from UK Atomic Energy Authority, and Frederick Pessu from University of Leeds, who has pre-recorded his session, will play it today. But any question and queries from our online presenters or those who have pre-recorded their presentation, you can ask, and we can ask them to provide their responses later on. We have two bonus online presentations, which are also pre-recorded, and you will have access to them after the event. So all the sessions will be recorded and will be available to you for review and rewatch later on. Really only available for the delegates today. But if anybody else is interested to watch them, they can contact ICorr Aberdeen, so we can see how we can access them. So before we start the keynote talk with by Bill Hedges, if anything from Preserve you want to mention about your demonstration in the afternoon? Okay. Yeah, okay, that's fine. So you can just reach out to him. I don't take much time of this. We're already a little bit late because of the setups this morning. So I will, by this, I will hand it over to Bill Hedges for his presentation. Thank you.
I've been told that I have to be off in 20 minutes, so I've got a timer on. Good morning, welcome everybody. It's absolutely fantastic to see you all here. Thanks for coming in person. We're struggling in ICorr. You know, what do we do? Now we've let the virtual genie out of the bottle, right? And it's so much more convenient being online and you don't have to go. But thank you all for coming along and taking a day out of your busy days, because I know everybody's really busy. So I'm going to talk a little bit about thinking a little bit about what ICorr is doing in terms of the energy transition, given that we don't generate any energy ourselves, of course, and a little bit on sustainability. And it's a fairly gentle introduction to the day. So hopefully, if you haven't fully woken up yet, you won't miss anything. Let's see if I can make this work. So a little introduction to ICorr. Roughly we have 1,500 members. For those of you who might be familiar with an organization called AMP, you know, just for comparison purposes, they have about 40,000. So, you know, we're talking a very significant difference in size of organizations. And historically, we've been big in the UK, but we're seeing kind of growth from overseas. So you can see now about a third of our members are overseas. And in fact, that raises an important challenge for us, which is, what do we do for our overseas folks? We've got people from all industries, I would say, and certainly been up here in Aberdeen, we've been historically biased to oil and gas. We've seen a lot of our members from oil and gas, but we're seeing that spread out now, in fact, as oil and gas sort of partially declines. Probably you would know what, I bet if I asked you who knows what our mission is, I'm sure most of you would probably have written it down in about 20 seconds, but to advance science and engineering in the prevention of corrosion. So that's kind of what we do. Actually, all these slides are available, by the way, so you don't feel you have to remember any of this. How do we do that? Well, I think, again, most of you will know education is a big piece of what we do, training courses for folks. And we go from the full spectrum, from apprentice. So for folks who might leave school at 16 and don't want to go to university or further education, they're going to do hands-on. They might become people who are going to do, for example, surface preparation, painting, early cathodic protection kind of work, all the way through to engineers. And as ICorr, through our alliances, we can offer various certifications and charterships. Things like meetings, networking opportunities. That's why we're here today. In some ways, the talks are just an excuse to get together and talk to each other. Certainly when I was working, I found coming to these meetings and talking to people in the breaks was where I got most of my useful information from. And we do a whole bunch of other stuff, including sponsoring students and social media. And we're running up here, thanks to the Aberdeen team, our young engineer program, which is a very successful program. So I'm guessing most of you have something to do with corrosion. And so when you think about the energy transition and you think about wind turbines and solar panels, you know, the kind of question is like, is there a concern about corrosion in the renewable industry? And is the renewable industry going to need corrosion engineers, or shall I stop now and shall we go home? I mean, you know, it's a really important question. So I thought I'd share with you a piece of work that was done last year. Maybe I will share it with you. Hooman, it's decided to not go on. Do I press this? Jammed completely. I have that effect on technology. A lot of my team to me say, Bill, stand away from the technology. So I'll do the introduction while Hooman's getting us up and running. But last year, Institute, try again. There we go, perfect. We did some work with the Henry Royce Institute, and some of you may have seen some of this, working with Fraser Nash. It was a study funded by the Engineering and Physical Sciences Research Council, just a bit of a mouthful, that's the EPSLC. And it was really a study to say, as the UK transitions to net zero, by net zero, I mean net zero greenhouse gas emission, what are the materials degradation challenges that are out there, and are there any things that could stop the UK getting to net zero as a result of corrosion or materials degradation problems? It was sort of focused on if there are problems, where should the UK invest its research money to make sure we solve those problems? So it had a sort of academic-y R&D bias to it. And it was a great opportunity to bring a lot of people together to talk about this topic. Perfect. I won't read these out. Focused on several key areas that you will all recognize for renewables. Hooman, well, that is going to go. It's just a bit slow, maybe. Make sure I got that right. Yeah. There we go. What we did was we did a survey of people who worked in all of those areas I showed you just now. And we had, these were kind of experts, right? So it wasn't just a general survey. We targeted people who sort of knew about these industries. And we got 41 people respond. I think we went to about 60. So it's a kind of 2/3 response. Many of those folks were Institute of Corrosion members. So we're very much involved in these topics. Several of the folks covered multiple sectors. So they work for engineering companies who do a bit of wind and a bit of nuclear. So some companies were across many industries. And when you put all of the responses together, we had 123 separate inputs. And you can see in the little graph along the bottom there are the different areas of renewables or topics that were being looked at for renewables and the number of responses. So you can see from that graph that there were good responses from experts pretty much in every area. And you probably can't really see this, and these are just the original colors we chose, so I apologize for that. But this is a heat map of the responses that we got from those surveys. So on the left are issues that came up from the experts, and across the top are the various areas, again targeting renewables. And the one thing I really want to point out is if you look in near the top there, along that bar there, whoops, very sensitive, along that bar there, corrosion is the one issue that is solid across every single topic, and it's also the darkest color, which means that actually corrosion was identified by all the experts as their #1 materials degradation issue. So if you are involved in corrosion and materials degradation in any way, you've got a long career ahead of you, okay? You're not about to disappear off the face of the planet. Lots of other opportunities were identified depending on time. We'll see if I can get to some of that. Back. So the outcome of that survey for the UK was that there were no showstoppers. That's good news. Yeah, there was nothing that people said we can't develop a wind turbine because we don't know how to solve this corrosion problem. There were no showstoppers, but there were lots of opportunities to improve. And I've put the contact down here, but if you actually go to the Royce Institute, you can get a copy of this report. So if you're involved in a particular topic like wind or carbon capture or nuclear, and you want to see what came out of that report, go to the Royce Institute and you'll find that report. If you have any problems with that, feel free to contact me and I can give you the link for that. And if you've got any questions, the lead on the project was Dr. Andrew Bofield, so feel free to connect with him as well. I probably haven't got time to talk about other things, so I'm going to go on, but depending on what questions come up, we maybe can talk a bit about that. Bottom line takeaway, no showstoppers, but lots of opportunity for corrosion work. So what about the energy transition? Well, I mentioned that the Institute for Corrosion, we don't generate energy. Okay, so that's not an issue for us in terms of what are we going to do about that. So the way we get involved in the energy transition is, as you will have seen from just now, many of our members are very much involved in that energy transition. Mentioned oil and gas, very active in certain areas of the energy transition. That would include biofuels, whether you're growing sugarcane to convert to ethanol, which we're all now seeing gently appear in our petrol for our cars, or whether you're into hydrogen or carbon capture, which is probably the only way that the oil industry is going to be able to continue to produce hydrocarbons. So really important work there. Wind, nuclear, batteries, you're going to hear a lot about some of these things today. So it's our members who are involved. So what we have to do is provide support for those folks. And again, you've seen some of this already. How do we do that? Training, obviously. Well, corrosion's still corrosion. If you're an offshore wind turbine, it's not really much different to be in an offshore oil platform leg, is it? There are some differences, but the kind of basic theories, the mitigations, very similar. So training, very important. Events like today, we have another the mini conference coming up next summer on sustainability. These kind of networking, getting together events, talking about problems, these are really important. Collaboration studies like the one I just mentioned earlier on, all go to support our members in terms of the energy transition. So I thought then I'd talk a little bit about sustainability. If you've ever looked up what the word sustainability means, you will find a gazillion definitions, okay? So you have to, in your own mind, come up with, well, what do I really think sustainability is? And kind of, when you distill a lot of it down, you kind of get to something around those first bullets there. It's a society goal. It's something we all know we intuitively want. You may not be able to describe it beautifully, but you know you want it. And really, it revolves around us using our resources wisely so that we can be around for a very long time. Otherwise, ants are going to dominate the world and we won't be around for a very long time. And there are some fundamental assumptions that resources are finite, and that's obviously sensible. And as I said, therefore, you really want to use them wisely. There are lots of different examples you can give on things like this, but where most people in this room are associated with corrosion, and most of that corrosion occurs on steel. So a good example is to look at steel. And again, some of you will know this, but this is a report that came out a couple of years ago by McKinsey. There are lots of reports out there on this topic, but for every ton of steel produced, this report looked back to 2018, there was an average of 1.85 tons of CO2 emitted into the atmosphere. 1 ton of steel, 1.85 tons of carbon dioxide. That's about 8. I've seen values as high as 11. Sort of people quote 8 to 11% of global CO2 emissions. So looking after steel is actually a really sustainable activity. And when we're, as corrosion engineers and practitioners, controlling corrosion, actually, you will do inherently contributes to sustainability. So we, as ICorr, you know, we don't produce steel, we don't make big things. What can we do? I mean, it's a much smaller scale kind of thing, but as ever, it's through our members that we can provide opportunities and solutions. So it's our ICorr members who do that. You know, there's just lots of examples. I've picked out one that I can give a longer list to, but if you look at the area of protective coatings, you look back over many years, so many things have incrementally gone towards being more sustainable. At the time, there are manufacturers of coatings in this room. At the time, they probably weren't thinking, oh, this is sustainable. They were probably thinking we can make more money this way, right? But actually they are sustainable activities. Things like reducing the level of solvents, you know, more water-based coatings, reclaiming solvents, where you can read the list here, reduction in, so I should spell that out, VOCs, volatile organic carbons, so things that get into the atmosphere. And even down to the equipment. When I was working on our offshore oil rigs, you know, we saw real improvements in the kind of equipment that people use to apply coatings, less wasteful, using less heat, safer for people. So lots of examples of that. And whoops, not quite yet. Go back one. I think I've gone back 2 there. Okay, so what can we do in the Institute of Corrosion ourselves? Well, one obvious thing, and we're striving really hard to do this, is increasingly we're paperless. So we, we have been a very traditional organization, and we like sending out forms. And if you are members of the Institute of Corrosion, you will know you get a letter in the post every year going, it's time to renew your subscription. And you then go, well, I'll go online and do that. And you couldn't for many, many years. It's really annoying. So we've now got, we can do online renewals and registrations. Our record keeping was all paperwork. Well, do we have filing cabinets of paperwork? And of course, when you're dealing with people's certifications, that's really important, yeah, because they're always calling up going, oh, when does my certification expire? And I'll lose my job if I don't, renew it. So this is now all going into becoming paperless. And Stephen's in the room here. He's running a project for us to say, how can we go even more paperless? How can we improve our website? How can we improve our databases? I mentioned earlier on, we've let this virtual genie out of the bottle. It happened over COVID. Okay, so pretty much before COVID, all of our meetings would have been in person, and that's great for networking. But it means people have to give up the whole day. Most of you honestly wouldn't be here for my talk. You'd be here for the wind talk or the one you really wanted, right? Going virtually gives you many opportunities, but there's something about physically being here and networking that is so important. Our training courses now, as we update them, we are including things like the energy transition and sustainability in those conversations. And meetings like this one to promote sustainability and the energy transition. I mentioned next summer, it's probably going to be in June, our Northeast branch based in Newcastle, which is where that conference is going to be, is going to have a conference on sustainability. Supporting students, sponsorships. We're probably going to give out less on oil and gas, if I'm honest, and we're probably going to give out more on things like wind and so on. And our young engineer program that the guys here are running really well. That's going to, I think every single problem we've given the young people, young engineers on that program has been an oil and gas problem. I'm thinking we need to get away from that. So if any of you have any great problems in wind or solar or nuclear, we'd love to hear from you on how we can kind of move in that direction. And so I would just end, and I've done reasonably well. Hopefully you may have some questions for me, but that's fine if you don't. But, one question I would throw out to the room is, what more should the Institute of Corrosion be doing in terms of the energy transition, in terms of sustainability? Are we missing something? I am very thick-skinned, so, don't worry about going, Bill, you guys are useless. You should be doing this. I'd be delighted to hear from you. So thank you very much. I hope you have a great day. I'm looking forward to the rest of it. Over to Ollie.
Thank you very much. Just one point, if you have any question, please ask for the microphone so the question and answer will be recorded, and then people online can hear you as well. There's one question online from Elspeth Allen. She's asking if they can have access to the link to the Royce study.
Absolutely. It's not, yes, absolutely. In fact, the more people who read that study, the better. Hooman, I'll send it to you, yeah, and then maybe you could send it out to everybody. Absolutely, yes.
Thank you. So the questions in the room, Dr. Oli can ask.
Okay, does anyone have any questions? Put your hand up. Okay.
I know, a question from the back is always the worst one, isn't it? When you start off.
Hi, Peter. I'm Stuart Rennie from Pressy. I've now got a question. You speak about the transition into renewables. As a part of the supply chain in the corrosion industry, in that transition, we see a lot of resistance in regard to older established technology remaining and a pushback on the introduction of new technologies. Just wondered what everybody else thought the best way to get technology embraced by the renewable sector.
Yeah, it's a great question. Maybe that's a question for the room as much as it it is for me. I mean, Stuart, I worked in oil and gas for 30 years. We always, and I half of my time was in central engineering and half of it was out in operations. And we always used to feel that we were about 10 years behind whatever the latest technology was. I mean, we were a bit of a transition slug. It took a long time. We were very conservative. I'm going to just take a slight digress there before I come back to your question. You remember, we talk about corrosion, right? We talk about integrity. And here we're talking about the energy transition and we're talking about sustainability. Corrosion control is about saving lives, right? What you guys do is about keeping people safe, keeping the hydrocarbons in the pipe if you're in the oil and gas industry, stopping things falling down, stopping bridges collapsing. It's all about safety. So we tend to be very conservative, Stuart. Yeah, it's not like, right, let's throw away all of that and we'll do, here's a new gadget and off we go. So I think as an industry, we are inherently slow to take up new ideas. So I think that's a great question for the room in some ways. How do we speed that up, but without being foolish? Yeah, because we've got to be very thoughtful about that. But yes, we are a slow industry. I mean, does anyone who want to actually give Stuart a proper answer on how could we speed things up? Any thoughts in the room? We've got some time.
Oh, if you can please say your name before you answer.
Yeah, it's Simon Daly from Safina Group. Yeah, you generally need a secondary need, I think, as well. And one of the big challenges we've always had within oil and gas on the coating side is how do you balance this requirement for innovation with a requirement for track record? Right. Generally, it's only when what you're offering solves another issue other than the primary one as well. And actually, I was thinking during the presentation when you're talking about sustainability, electric spray pumps, as an example, how much time and effort and money do we spend, diesel, emissions associated, fuel usage? You wouldn't get that transition until all of a sudden the cost of diesel is as high as it is. So you need to have that secondary need, I think, to layer on top of the primary benefit that you're offering.
Thanks.
Thank you very much.
I would also say, I think some of the renewable industries, be careful how I say this, have been a little bit reluctant to take hard lessons learned from other industries, maybe like oil and gas. I mean, is painting an offshore wind structure that different to painting an oil and gas platform? But there seems to have been some reluctance, which I think is changing today. But that's been a problem in some of the renewables industries as well. Yes. Well, sorry. This is sorry to be a pain.
Hi, it's Sabina from Wood. I was working for offshore wind, so I can tell you, not painting the structure. It's not about being reluctant, it's about trying to save money. Because you can have in a wind farm 50, 100 turbines, and they can go up to 50-meter deep water. Yep. So, and painting all of them, that's a challenge.
Absolutely.
And it can go up to like 10-meter in diameter. So, I mean, even just having workshops where you can actually paint that's really challenging. So I would say they really want to do that, but I don't think sometimes they can afford that.
I think that's a very honest answer. Yes. Thank you for saying that. Yeah.
Okay. Please say your name before asking.
Thank you, Bill. Stephen Tate, the current Vice President of ICorr National. I would just like to point out that within ICorr, we do have a corrosion engineering division, which holds annual events and probably more frequent events going forwards. We've set up a new all energy group that covers all types of energy. That would be under the chair of Steve Patterson, that many of you will know from Shell. So we're very much looking forward to taking that forward in 2023, more activity under the all energy division. Thank you.
Yeah, thanks, Stephen. Really, really good point. And actually, if anyone has any suggestions for topics for conferences or events, we'd love to hear from you, because we can lay them on, but we need to know what people really want.
Okay, do we have any more questions from our audience in person? Okay, I've got one for you, Bill. So what would you say is ICorr's biggest challenge at the moment going forward?
Great question. There are a few, but I think I would pick on something that is actually affecting many organizations today, whether it's institutes or bowls clubs or religious societies. It's finding people who are willing to volunteer and get involved. And that has become such a big problem for us. It's not that people aren't willing, they just don't have the time capacity. When I was small, and that is a long time ago, my company used to actively encourage you to get involved, 2 days a month or whatever. And today that is so much harder for companies to provide that time to get involved. So one challenge we're facing is getting people involved. And when we do need to get people involved, for example, if we want to update a course or something like that, we're finding now that there are some great people to do that, but they don't have the time. So we have to pay them to find the time. And so we're slowly going through this transition of hoping desperately that people will volunteer their time. And if you've ever volunteered for the Institute of Corrosion, please come and tell me, and I'd like to thank you personally, because thank you for that. But we are finding we're transitioning and maybe going more to what I would call the AMP model, or the AMPP, whichever model name you want to use for that, where we're slowly transitioning maybe to become in more of a business. So I'm also going to say thank you to our sponsors today as well. Thank you, Stopac as well. We really appreciate that. I mean, you can't do anything without some level of money, and goodwill takes you so far, but thank you to our sponsors for that. I'd say, Ollie, biggest challenge, managing this transition from a purely volunteer organization to a sort of, at the moment, a mixed model, where thankfully, when we do pay people, we often are able to pay mates rates. That's the term that gets used, where normally they might charge this, but they'll do it. They can't do it for free anymore, but they might do it for half the price that they might charge out on the commercial thing. Great question. Thank you.
Okay. Are there any more questions from our audience in person? Do you have any more questions online?
Perfect.
Okay. If that's the case, I'd like us to thank Bill in our usual way. Thank you very much, Bill. Okay, thank you all very much for coming. I'm Ollie Latinwell, Vice Chair of Aberdeen ICorr, and I'm going to be the Master of Ceremony for today. So thank you all for coming, and we'll get to the meat of our presentation. So the very first one based on the agenda will be, we are going to be starting the competency and training session. So obviously this is very important, as we're all going to be transitioning and we're all going to be coming into this from a wide range of skills and industry backgrounds. So it's important to know where we're going forward. So fortunately we have Muhsen Elhaddad, who's going to help us take us through some of that journey from a corrosion engineering perspective. So before we start, I'll just give you a brief introduction into our speaker today. So Dr. Muhsen is going to be giving a presentation on roles of corrosion professionals during energy transition. He is a corrosion and materials professional with more than 20 years experience in international oil and gas companies, both upstream and downstream. He has made outstanding contributions to increasing awareness of the important corrosion and corrosion protection strategies amongst government, industry, and the general public. He started his career as a corrosion engineer and devoted most of his time and experience in raising public awareness of the risk of corrosion in national and international communities. He was elected as Qatar Corrosion Community Chairman in 2018, and since then has been working to bring out improvements in the region's activities and strategic focus. He has committed most of his time to build stronger relationships with education associations in Qatar to promote a better understanding of corrosion and risk-effective mitigation strategies. He He also likes to write a lot. So he has provided several training and awareness sessions for senior graduate students at Qatar University, North Atlantic University, and the University of Manchester. He has a BEng in Material Science, an MSc in Material Science Technology from the University of Qatar, and is currently pursuing a PhD in electrochemistry at the WITS University. He works as senior and well integrity engineer at Qatar Gas Operations, and is also been a principal engineer at a lot of cleaner energy projects going forward. He holds various qualifications from NACE, API, ISO, and he's an active member of AMP, ICorr, SOE, EFC, and holds international lecturing certificates from University of Cambridge. So with that, I'd like you to please introduce our speaker, and I hope you enjoy this presentation. Thank you very much.
Thank you very much. I hope you can hear me. Can you hear me?
Yes, we can hear you.
Okay. Good morning, everyone. And it's good catching up with old friends, and also to see Bill active as always. He has been our guest in April in Qatar here. So, as you know, efforts to increase the sustainability of energy systems in Europe are ongoing. With renewable energy targets set for all European countries, and the goal of the European Union members to become the world #1 in renewables. As per the International Renewable Energy Agency, the EU has adopted targets to achieve 20% share of renewable energy and consumption by 2020, and 32 by 2030. So many countries have already started decreased reliance on fossil fuels and adopting clear plans to achieve net zero emissions. As corrosion engineers, we are, as you know, corrosion engineers and material engineers are invaluable assets to support smooth transition to cleaner energy. Therefore, I tried to put a couple of slides where we need to be prepared with mitigation strategies of some potential corrosion damage mechanism. The agenda of the talk will be a brief introduction, brief corrosion statistics, corrosion management elements, what are they and how we can implement them, energy transition overview towards cleaner energy, hydrogen integrity. I'll try to focus on hydrogen integrity challenges, and then we come up with conclusions and key takeaways. Today, we are challenged as professionals to ensure that the safe operating of our assets. To meet these challenges, we must ensure that our assets are all the time have long-term reliability and optimal performance. These demands do not come easy, as you know, and not always met, as history has shown us and challenged us basically and mainly because of corrosion threats. And many of these failures could have already been prevented, should have the knowledge and level of expertise been shared and cascaded down to other stakeholders. This is a brief review of 2013 Joint Research Center report issued by the European Commission, where it highlights the 10 largest hydrocarbon losses. And of the 137 major accidents reported by the EU since 1984, around 20% indicated corrosion failure as a primary contributor for the cause. And a study also identified that 40 accidents occurring since 2000 involving corrosion failure as a particular cause of concern. And in 53 cases, process conditions were identified as contributing factors as well. So it's very challenging for corrosion engineers, because corrosion engineers, they need to know the properties of the material, the severity of the environment, and the interaction between these two to be able to mitigate the risk to the as low as reasonably practical. And this is the ball chart shows the losses in terms of value from 1988 to 1989 and from 2018 to 2019. And you can see these are the major losses we have encountered historically. Louisiana incident, which has contributed of a loss of more than 700 million, was happening because of the fluid catalytic cracker unit internal corrosion. And a similar incident happened also in China with a 800 million loss. And this was actually one of the biggest and most severe incidents in petrochemical plants. It resulted in more than 78 fatalities and 617 injured. The plant has been operated with the repeated safety concerns. And this is also another challenge that we as corrosion engineers and material engineers, we need to be very vigilant, understand the interaction of the environment and the consequence of the business we are doing. A quick reflection on maybe you have already come across this. ABI 2014 has issued an advisory report trending the losses of the pipeline from 1999 to 2012. And this report has indicated, which is good, reduction of corrosion releases over the last 14 years. However, this report highlights that corrosion remains the second largest cause of oil releases. Corrosion happens internal and external, so it was a combined effect between internal and external for the pipelines. That's why solutions should be understanding holistically the environment from internal and external. External atmospheric environment, as I heard the team highlighted about solar panels, and also the solar panels and wind turbines. Atmospheric corrosion poses the highest threat because of the degradation of the metallic materials. So as a kind of a quick conclusion, that we agree that corrosion is still a major concern to all sectors of the economy, and losses of corrosion can contribute to more than 3.4% of a global average GDP. It's estimated by the American Water Works Association that the replacement cost of the corroded infrastructure and the water pipes would exceed more than 325 billion over the next 20 years. So you know that water is an important supplement for our lives. That's why corrosion engineers need to exert more efforts in coming up with the new technologies and solving the existing issue. And so we all know that corrosion can be controlled through adequate, for example, fundamental understanding of the physical principles of corrosion, through good design of engineering instructions to render them corrosion-free, or through good monitoring and inspection. To maintain actually awareness about the corrosion threats of changing conditions, to optimize response, analyze failures, and share knowledge, which is very important. As Bill highlighted, sharing knowledge and engagement with communities is very, very important key parameter in mitigating and preventing corrosion. So why we haven't succeeded so far? Is it because of the cost, economics? Is it lack of knowledge of the consequence for some operations, especially the petrochemical plants? Is it terminology limitation? Or I heard the question from the background about how fast we are moving for the energy transition. So this is very, very important to understand or to assess the potential damage mechanism before we engage with a high impactful energy transition that could result in a fatal or unfortunate incidents. So I think that the best approach is that as a team, as a community, as companies, we need to embrace principles of corrosion management and asset integrity management system as individuals and as communities as well. So which is really represented in this quick schematic that initially we need for every aspect of operating a facility, we need to understand, identify all active and the future corrosion threats, then mitigate, define and implement mitigation program to control these threats, then apply an effective monitoring system. It's not a matter of applying a monitoring system that is not representing the worst case scenario or the worst case expected damage mechanism. and then measure our performance by feeding also the lessons learned from other companies, sharing studies from other companies, and not try to reinvent the wheel, because sharing knowledge can save us not money, but also lives, which is also in line with the plan, do, act, and check cycle. So world, as I said, is trying to push for energy transition as fast as possible. The world has already been facing major challenges of the climate change, and there was a pledging to reach net zero carbon dioxide condition that will be limiting temperature rise to 1.5 degrees, and which is targeting 8.8 less CO2. In 2000, which is good actually, in 2019 and 2020, there was a reduction of CO2 emission by 8.8%. But this may be attributed to the COVID restriction and the limitation on some of the operations. So we should not be very happy on this, but we need to exert more efforts to reduce it more and more dramatically. The energy transition requires a major shift of electricity generation, of course. And the good thing that highlight or recommendation was highlighted by IRENA, International Renewable Energy Association, that green hydrogen can provide a link between a growing and sustainable renewable electrical energy, and the hard to electrify sectors. So what are the avenues that are required to ensure that we succeed in reduction the CO2 emissions? This is a kind of a bar chart that was issued by the International Renewable Energy Association, identifying 6 technological avenues that will be invested to ensure that we will be able to tackle equivalent of 36.9 gigaton of CO2 emissions. And you can see here, hydrogen represents 10%, which I'm trying to focus in this slide on green hydrogen. Key milestones also put by the International Association for the Rapid Emission Reduction, that as you can see, the gray and the brown bars are dramatically increasing from 2018 to 2030. And this is because of the expanding of the other renewable energies. So one solution for hitting these milestones is by ramping up renewable together with an aggressive energy efficiency strategy, which can be done as per the International Association. The good thing for us and for the future engineers that it's predicted to have an increase in the energy transition related jobs around 85 million by 2030. And this actually putting an additional challenge for our educational institutions and universities, that to meet this demand, we need to equip our students and high caliber force with the capacity to be able to fill these requirements confidently. And this also requires, as I said, scaling up of education and training programs to meet this requirement. Green hydrogen, there is a global interest in rising in green hydrogen as an alternative solution for an energy transition towards zero or net zero emissions. There have been several waves of interest in hydrogen in the past. However, this new wave places a broader focus on creating a link between renewable electricity and hard to electrify end uses. Indeed, the last 2 years, I remember, have been witnessed increased momentum for green hydrogen, with many countries around the world implementing national hydrogen strategies or announcing their intention to do so. An additional promise also for hydrogen to be able to provide the fuel for different applications like power cars, buses, and even spacecraft. The good thing about hydrogen, as you know, it's abundant chemical in the universe. When it burns with oxygen, it produces water. So from environmental perspective, it's friendly, safe. But from a corrosion perspective, water is is where we need to apply more mitigation as well. This schematic represents the green hydrogen production, conversion, and end uses across the energy. You can see that there are, as you know, 4 common shades of green hydrogen, depending on the process from where they are generated and the source they are bringing them from. And the most friendly and environmentally friendly is renewable electricity based on green hydrogen. However, there are current challenges to uptake of green hydrogen. As you know, limited dedicated transport infrastructure is there. There are only about 5,000 kilometers of hydrogen transmission pipelines around the world, compared to 3 million kilometers for natural gas. So there is a big gap between existing and the future, but there is studies and review to utilize or rehabilitate these pipelines for future use of hydrogen transportation. So natural gas infrastructure could be repurposed, as I said, for hydrogen to lower the cost. And for the storage, hydrogen can be stored in steel tanks or underground geological formation. However, there are a couple of challenges like hydrogen embrittlement that could yield the material integrity compromised. Currently, Germany is already planning to convert 5,900 kilometers of its natural gas pipelines to hydrogen, which is around 15% of the total national network, with the first 1,200 kilometers to be completed by 2030. So there is a kind of bottleneck for the full utilization of green hydrogen. Integrity challenges, you know that hydrogen is difficult to store because of its lowest atomic size and the ability to penetrate through materials and to create what's called hydrogen embrittlement. It can diffuse into the atomic lattice and deteriorate the mechanical properties of most of the materials. Hydrogen can cause cracks, and we have seen incident for the TMCB pipeline. These are pipelines produced through the application of controlled mechanical properties. And the reason for that was hydrogen embrittlement. And I think there is two very, I would say, informative presentation coming up for the pipeline to address this in more details. Hydrogen could also induce assisted cracking, reduction of fatigue resistant, and the reduction of tensile ductility and notch toughness. The right schematic on the slide represents the downhole completion, a typical downhole completion, and most of the application now they use CO2 injection wells to inject CO2. So it's expected that they will be utilized also similarly for H2. However, there have been reported cases where, due to the variety of the metallurgy downhole from cobalt alloys, high nickel alloys, martensitic stainless steel, and copper steels, there are chances that some of the safety critical elements like downhole safety valve will be compromised. And I have seen a couple of incidents before where the cobalt springs have cracked before of the hydrogen embrittlement, and also generation of the hydrogen gas in the well annuli. This also builds the pressure in the well annuli and makes operating the wells very challenging, because you need to do a higher bleed down and also monitoring of the buildup, because as you know, hydrogen with oxygen can be very, very flammable. As I said, hydrogen embrittlement risk can also be avoided by carefully selecting of chemical compositions and steel, making them less vulnerable. There is quite research now is ongoing for modifying austenitic stainless steel to be able to be utilized for a safe storage and handling of hydrogen environment. One critical aspect that we need all to be aware of, and this is, I think, supports one of the questions that was raised in the audience about how fast we go and what are the showstoppers expected for a specific energy transition, is the abundance of the critical elements. As you know, the EU has identified critical elements as the elements that is very important to major industry and which supply is or could become problematic. You can see on the left side delivery risk of these elements. So the higher being the most critical one, and the material is, for example, the light rare earth metals, the heavy rare earth metals, and these metals will go in many technologies, and the sector will be limited by the availability of these elements. So if we are pushing for energy transition and ensuring that we will be utilizing different technologies, we need to ensure that the input elements or the critical elements are available for everybody to be able to have a smooth transition. And another important aspect is the country where we obtain or supply the critical elements from. And this kind of geopolitical situation around the world is also affecting the global energy transition, because as you can see, the biggest country has bared the sustainable energy system from the International Renewable Energy Association. China is the biggest provider for a number of metals that are important for many technology applications like electric vehicles, solar PV, and wind turbines. So it's very, very critical for corrosion and material engineers to be able to select the elements that they will not limit the technology expansion either currently or in the future. So where we are expecting contribution of corrosion and material engineers, we need to have a proper stewardship of our corrosion and control mitigation strategies to ensure that the proper material is selected to handle safely the H2 environment. The use of ABI 5L, I think there was a study in the UK to requalify the higher grade pipelines to be able to safely store and transport hydrogen. And it found that hydrogen service has been proven to be operating up to 140 bar with no reported issues. Another challenge is people are exploring is to limit the operating stress level in the pipe to 30%, but this of course limits your yield, strength, and other mechanical properties that you may require for your operation. And pipeline design operating history, as well as a comprehensive internal and external inspection, should be considered when converting existing subsea pipeline to hydrogen service. And that's why we usually do is to reassess the condition of existing pipeline and to have a robust inspection validation tasks to ensure that the current condition is not jeopardized by the earlier service and also will be fit for service for the coming operation. And there was a recommendation to have hydrostatic pressure and leak test may be required for the pipeline before repurposed for hydrogen application. Okay, so 4 R's, they were introduced, and I think this is we need to hold in our hands every time we want to transfer or transit to next generation because of the availability of critical elements is to rethink. First, incorporating material perspective when designing the energy system, then reduce promoting technologies using fewer critical elements. If we can avoid those critical elements from being used, yes, we can. And then the other R is repair, refurbish, and repurpose. If we can repair and refurbish and get more metals from recycle, that will be very useful. And then recycle, recovering materials from decommissioned energy products to create secondary material flow. Conclusion and key takeaways. As corrosion professionals, we must continue to play a major role in delivering the means to have an effective corrosion management system in place that will, of course, protect people, assets, and environment from the adverse effects of corrosion. And corrosion professionals need to engage with their management to demonstrate the need for corrosion management and its value, And we usually say, as safety people always say, safety is up to me. And we also say corrosion management is also up to me. So it requires everybody's contribution. So corrosion is not a job, it's a profession that needs passion, skills, and commitment. And we need to have more engagement of the technical societies locally and globally to ensure that the knowledge is shared towards effective corrosion control. And I'm very happy to see these kind of forums happening in ICorr Aberdeen. And corrosion engineers need to be prepared for energy transition by having the correct skill set and tools, understand the critical parameters, the critical metals, and the interaction of those metals with the environment to be able to effectively mitigate the corrosion threats to the acceptable level. I need also to explore solutions to mitigate surging demand for critical metals, as I said. I think that's all from me. I hope it was try to push quickly for the time's sake. Thank you very much for listening.
Thank you very much. Can you hear me?
Yes, I can. Yes, I can clearly.
Okay, perfect. Thank you very much for that presentation. It was excellent. So we will ask the floor for if they have any questions for you to start off with, and then we'll deal with the questions online. So does anyone have any questions today? Okay, everyone's shy to start off with, so I'll start. So first question for myself would be, you mentioned that we need to increase engagement. So what would be your strategy in increasing engagement with materials engineers in the industry?
I think, as you mentioned, being shy is one of the barriers for learning and for spreading knowledge. So the best way is to increase engagement based on the kind of discussion we had, is to have discussion and increase the public awareness of corrosion threats in the inception stage of students, like, for example, secondary students or graduate students, other than waiting for them to graduate. So we equip them with a required skill set, conduct more outreach programs to engage those students, because not all universities provide corrosion engineering as a separate degree. Usually usually universities provide metallurgy, chemical engineering, mechanical, and then it will be up to the student to choose. So we need to extend our hands after we have crossed this kind of time to the fresh graduates, make them aware about the corrosion threats and how they can contribute for a safer community.
Okay, perfect. Just to follow up from that, what about graduate schemes? Do you have any opinions on those, and maybe perhaps standardizing them to make sure that everyone gets a similar level of training going forward?
Yeah, we personally, I received one complaint from one of a graduate student that corrosion was put as an elective subject. So some lecturers, they may say, okay, this is elective, so will be offered this semester, will not be offered the second one. So we need, as corrosion communities, to ensure that those kind of subjects will be mandatory requirement for graduates, and then have an internship where students will be directly engaged in the corrosion activities rather than in a different disciplines.
Okay, perfect. We have a question, I believe. So I'll just pass it along. Please state your name before asking questions.
Good afternoon, Muhsen. It's Bill Hedges here.
Oh, it's nice to see you again.
Good to see you, my friend. Muhsen, Qatar has a long history of oil and gas production. What do you see as being the most promising new energy sources for a country like Qatar?
Yeah, I think this is a big question, but based on my experience and being residents for a while here, I think LNG is liquefied natural gas, is still one of the biggest commodity for energy since it's clean. And in the Middle East in general, in other countries, they are putting pledges as well to ensure that the emissions out of the LNG operations will be minimized to ensure that smooth transition. However, one of the key actually promising fields that already I think companies here and government have already started investing already and they have plans is the solar energy. There are a couple of big projects are coming up and it's open to public that they will be having solar panels. Considering the environment here and the hot atmosphere here, it will be a very profitable industry in here.
Excellent. Thank you very much for that. Do we have any more questions in here, in our audience here? Okay, we have one more. Please state your name, Steve.
Stephen Tate, thank you. Good afternoon, Muhsen.
Thank you.
I'm just going to say in terms of conversion of oil and gas pipelines, there's obviously going to be need to have a big program of intelligent ILI pig runs and sampling, because there's always very good records of construction of the original pipelines, because many, especially in the UK, many were built in the early 80s, late 70s. So we have quite an old infrastructure in the UK that would need thorough inspection before any conversion was considered. Thank you.
Yeah, it's a good question, really. Yeah. So refurbishment of an existing pipeline to be fit for service for a future hydrogen, as you said, will require a thorough inspection, considering the limitation of the existing ILI for picking up hairy cracks. And also we will need to revalidate the safe operating envelope of this pipeline based on the current ISO 15156 requirement as well, because based on the field experience, we may be able to qualify the pipeline, but we need to understand or meet all the mandatory requirements to be able to qualify, as you said. So inspection will be thorough, and maybe it will be a kind of ABI 579 fit for service, either level 1, level 2, or level 3. But indeed, yeah, I echo your message that it has to be thoroughly inspected and assessed.
Thank you very much for your answer there. Do we have any questions online?
There are 2 questions online. There are 2 questions from Orvish Wala. What is the threshold temperature for hydrogen embrittlement for pipeline and material of construction of cross-country pipelines?
I will answer this based on the being a committee for the task group 299. So to be able to mitigate hydrogen embrittlement, the lower the temperature, the more risk is, because you will not have time for hydrogen atoms to combine and like penetrate and go like methane gas, for example. So the lower the temperature, the higher the embrittlement. And I think maybe the coming pipeline presentation will be addressing this in more detail, but it's very challenging to quantify there is a specific temperature there, because if you go higher ambient condition, this will be very challenging. And if you go minus, that yields you to the ductile brittle transition. So it's very challenging, but we need to ensure that the material microstructure is clean and meeting the H2 hydrogen embrittlement requirement, because the ISO 15156 it makes it or gives it to the end user whether he needs to do any HEC testing or not required to do HEC testing, depending on the cleanliness of the product. So there are a number of factors that need to be looked at, and temperature is one of them. Yes.
Thank you very much. The other one is that the changeover of a pipeline from the natural gas to hydrogen need other cleaning requirements based on hydrocarbon product deposits. Do you agree that?
Yes, for a pipeline, we frequently use pigging to ensure that there is no deposition in the pipeline, because, as you know, deposition can induce under deposit corrosion, which is unpredictable damage mechanism. So there is no, as far as I know, a current methodology or simulation that can simulate the corrosion behavior under deposit. So it's frequently non-linear, maybe logarithmic, maybe different, but it's very challenging. That's why we need to have clean pipelines to ensure that corrosion prediction is a kind of systematic and understood by everybody. And this also adds to the point that the threat for the dead legs, which we know that dead legs as defined by API, any dead leg that or any pipe that does not see significant flow for more than 3 months. Some practices, they say more than 6 months. But if you have a dead leg, the risk of getting corrosion is very, very high. That's why there should be flushing and systematic and more frequent inspection to ensure that we don't lose the wall thickness because of this high corrosion rate damage mechanism.
Thank you very much. Do we have any more online questions? Come in. Do we have any more questions from our audience today? Okay, I'll have one more question for you. So you mentioned that we should potentially be converting our hydrogen, so our subsea and pipelines and onshore pipelines for hydrogen transport service. So with a lot of these legacy lines, there might be some issues with understanding the old metallurgy of the lines because it's not well documented. So what do you feel is a factor in overcoming that going forward and also providing some form of asset life extension for them?
This is a good point. So one of the requirements of the asset life extension is to understand the predicted corrosion damage and also the existing conditions. So if you don't have the data to validate your assumptions, then the best maybe approach is to use a similar pipeline for a similar service for a similar production date. Then you can use it as a reference as recommended by API. However, to remove this uncertainty, you may need to have more inspection runs or more ILI techniques to ensure that you pick up even small bittings or small hairy cracks. That's the challenge. If you have cracks, add different metallurgy, because hydrogen may pose different effect for different metallurgy. So the answer to your questions, if you don't have data available for an old pipeline, you need to increase your confidence by having a more complementary inspection techniques to cover up all the credible damage mechanisms that you are expecting.
Perfect. Thank you very much. So do we have any more questions? Okay, so I'd like to say thank you very much for your presentation. And most importantly, thank you for assuring everyone in this room that they'll still have jobs going forward in the energy transition future, which is the most important thing for us all. So thanks again. And we'd like to thank you in our usual way. I hope you can hear us. So make it loud and proud.
Thank you very much for your attendance. And I still, I think Bill owes me a meeting that we need to engage more with the Institute of Corrosion. So we'll have maybe after the forum, another meeting with Bill to engage more with the Institute of Corrosion, with the community here.
Yeah, no worries at all. And hopefully events like this will make the world a little bit smaller. So you're more than welcome.
Yeah.
Thank you very much.
Appreciate the time given to me. Thank you very much.
Okay, and just one more thing. If anyone would like to contact you further with any more information, how can they reach you?
I have a LinkedIn page. I'm trying to be active in there, but reach out to me and we will be able to have more chat on this. Yeah.
Okay. Thank you very much. Much appreciated.
Thank you very much. Thank you.
Thank you.
Okay. So that brings us to the end of our session on learning and competency and development. So we are now going to have a break, and I'll ask if we can reconvene for 10:30 where we can start off our next session. So thank you very much.
Quite detailed comparison.